Hi, I'm here to provide you a return of experience of a system designed to detect infected computer on company's network, looking at the DNS traffic resolution. So it's a response to a contextual problem. It's absolutely not proper, you will see. And I also have the objective to gain skills. So sometime I reinvented the wheel. First, I will talk about malware trap, the infected computer detecting system, which catch zombie. And on the second part, I will talk about domain trap, which aim to catch domain generation algorithm. So first, malware trap, the context, it was in a major French company in logistics, in a small team, the computer incident response team, a small team which was responsible to supervise a very big network. And in late 2010, they discovered a Mariposa infection, one of the biggest they encounter. Of course, the AV support was unable to contain the pollution. And of course, the AV update was made sample by sample, and the sample were the one discovered by the company's CERT. So they had the idea to sync the domain they identify and localize the source with the source address. 2 days of development. So basically, when an infected computer want to reach his bot controller through HTTP, it goes through a domain name, and when a machine wants to contact a domain name, it doesn't contact directly the domain name. It asks to the DNS server an IP address. But in the company's network, there were an internal DNS zone, so the DNS returned NX domain, so we don't know. And the idea was to force the CNC entry and to put the IP address pointing to the firewall they control. And then they collect the log. They launch an Nmap to the source address to collect NetBIOS information, MAC address. They knock to the AV agent port to collect AV agent information. All this information was put into the CAV file, transferred to a FTP server, and when they have the time, they look at it and try to do some remediation. So even if it was very simple, the remediation was great, better than the AV provided. But it needs improvement. They wanted to improve the things, and so they asked me to do it. And with the first goal was to detect the bot and send the alert not to a FTP server, but into the CM, so that the security operations center could treat the problem. No problem. We can start. So from their needs, I start to identify the functionality we need. So detect and alert functionalities, the part to update the DNS name, module to do some statistics and intelligence, and shared functionality shared between the 3 other parts. And we come with this graphic. Just focus at the colors. So red, detect and alert; green, DNS update; orange, statistics; and the MTDB malware trap database, which is shared by all of the functionality. And domain trap here is just for information. It's not part of the system. You will see why after. And the machine, it was a virtual machine, nothing, it's not cloud computing. I had 3 interface Ethernet address, and from that we can start the real thing. So we start to do the communication part. So we configure our Ethernet interface with IP address, and on the ETH1 there was 1,000 IP address in which coming the infected communication. And we start by the drop, collect the log. So one line of IP table, and if you want a standalone file and not be put in the /var/messages file, you do a chain, IP table chain, 3 lines of code, and in the rsyslog.conf 2 lines of code, and you have your standalone log file. Then we have to collect the log and send it to the CM. So the script called Mouchoux does that. It takes the log, it collects the source IP address, launch the nmap scan, retrieve the information, wrap it to the syslog format, and send it to the CM. And to launch the script periodically, we use cron tab, 1 line. And done. It's coming into the CM. Then, stage 2. We put in place the malware trap database along with a script called tote, which is responsible to read and write into the memory. So the database is composed, it's MongoDB, it's composed of 4 collections. Domain TWAD collection, that's where are stored the domain we want to put under surveillance. Active TODEL collection, that's the domain we are supervising but are not anymore malicious, considered malicious. Active collection store the domain currently under surveillance, and host collection, it's a backup of the log sent to the CM. And we have the script with several parts which interact with the malware tab database. Then we have the script Heimdall, which crawl DNS reputation blacklist. So in this case, 2. And there are 2 parts, Pizinoe, which collect all the new malicious domain, and through 2 CSV files, they are on a pod, which can be digested by the top script. And the second script is Anku, which make a diff between what we are supervising, what the RBL tells us it's malicious, and if we have domain name that are not in the RBL, we have to suppress it. So one of the CSV file was to do an attribution between an IP address and a threat. Why do that? Because remember the basic concept. The infected computer asks the IP address of the CNC to the DNS, and then it contacts domain trap with an IP address. So we lose the information, the link between the domain name and the threat. And to do that, that's why we had 1,000 IP address on ETH1. And for each IP address, we map it with a CSV file, the threat, the corresponding threat. So in this case, in the first /24, I put cybercrime threat. In the second, APT, and there are 2 available slots. Stage 3, it was statistic, so there are no great interest to present you the statistic script, but more the statistic itself. And during 1 month, there was more than 600,000 events produced by 100 unique hosts for 1 threat, Mariposa. And it was interesting to see that among all these events, 90% were produced by only 10 machines. So that was the one we have to deploy the more quickly. And just for information, it takes about 500 hours of work, and about the half was spent in meeting, negotiation, etc. So, domain trap. Domain trap was at first a personal development, which was incorporated in the CCIRT project, and I worked on it at the end of 2011 and at the beginning of 2012. And all started by a troll. So I was in a separate room with the contractor, and at the lunchtime, I love to take a paperboard and do a troll math problem, because they love math, and that make them mad. And one day comes a counterattack, and one of them say to me, "Okay, please do something to detect this kind of string." And this kind of string are domain name generating by a domain generation algorithm used to improve the resilience of a botnet, of the infrastructure. And when we look among this algorithm implemented in several botnet or threads, we see that some algorithms are time dependent, some don't, some are deterministic, some don't. And I wanted an approach that doesn't regard this kind of profile. So, like I'm more a guy that loves words than math, I wanted to do a word approach, and based on what we saw when we are reviewing logs, as a human, when we saw string like that in a domain name, we know that something is wrong. So the idea was to code the process of our brain that come to the conclusion that it's malicious. And for that, you can count the number of dash. You can try to do percentage of the rare letters. You can compare it to a French and English word. So it was in a French context. So if you have another language, you take another dictionary. You look at the entropy, and you look if you already know that the domain name or the TLD is not to be abused. So the first rules were grouped in Sasha. It was coded in one afternoon with the time to learn Python, and it detects 65% of DGA about. The second street, Shannon. So the idea was a string is not close to a French word or an English word, so we are looking to distance algorithm, and there are too much character diversity, so that's entropy. So the first Shannon version was based on Levenstein and Shannon. Basically, Shannon is the quantity of information contained in one message. So if the message is Toto, there are two information, T and O, and then you do the math, information divided by the longer of the message, and you have the entropy. And if you have a low entropy, it's like the string have a lot of redundancy, and high entropy, it's highly random. And Levenstein distance, the idea was to put to do a Levenstein distance between the string you want to access and the dictionaries. And the idea was that there will be a separation between a real world and random string with a curve a bit like that. That was the idea, but we will see that it's not so simple. And how it works, so Sasha and Shannon has all their rules, they aggregate it, they send it to the domain core, there are another level of aggregation, and it gives a score between 0 and 3. 0 probably clean, 3 probably malicious. Also the idea to do an ADA based on Bayesian filter script and Matari, which was not realizable. So time for improvement, but you will see that it's not because we do an improvement that the solution is better. ADA, so it's based on Bayesian filter. It's sometimes used in anti-spam filter. And you have to construct a knowledge database. Then you split your FQDN into TLD, domains, subdomains. And regarding to the indicators you want to assess, you do the math, and it gives you, without regarding the context, a statistical reference. So with this database, you see that if you have an FQDN with a .fr TLD, there are about 30% of chance that it's malicious. For improvement, I also removed the www subdomain, which was not relevant. I transform international domain name into Latin string, so for Cyrillic alphabet, but it don't work. And I remove the TLD for Ada and Shannon, because it was not relevant. Sasha, the most of the improvement was focused on the speed. And the first version, the value I put for the trigger come out of nowhere. It was intuition. Then I do some statistical analysis on the traffic soft habits of the internaut of the company. And we have, for example, here's a character used both in legit domain and in malicious domain. And we can see, for example, that numbers are way more used in malicious domains than in a legit one. And it can also show some letters like Z, X, J, K, which are more used in malicious domain. And with this information, we can do our where letter collection. Shannon, so Levenstein was a great idea, but the first time I do the thing, I restrict my score table to 16 because I thought it was already a big distance, but it was not, and it was totally not relevant. So there was absolutely no segregation between legit and malicious. So legit is in blue and no, legit is in red and malicious is in blue. It's very logical. Sorry. So with deception of the Levenstein performance, I tried to search new algorithm. So I focused on distance algorithm and also on phonetics because I didn't mind that if it's not readable, it's not pronounceable, and I think there are a lot of things to do with phonetic algorithm. I also review the dictionary approach. So in the first version, the string was compared to the word dictionary, and now it's compared to a short list made by words that share 66% of common bigram with the string you want to assess. And I put 66%, but it's random. You can change it. And from that, the build of the shortlist, you are highlighting first rules. If the shortlist length is 0, it's suspicious. And then we can see the result of this improvement with a better segregation between legit and malicious domain. So finally, I choose demo Levenstein distance algorithm with the bigram shortlist. I use Jaro combining with match rating codex. So match rating codex, it takes a string and it gives a kind of abstract of the pronunciation of the string, and it gives different results than just the gyro distance, and the segregation was not so bad. So gyro, the regular one, match rating comparison. So with that, we are able to see domain names that play with the word, or that give where the phonetics is the same, and the Jacquard distance. So finally, the result in the canaries context, it detects all the DGA and a great part of the malicious domain, thanks to ADA, the Bayesian filter, and there was some false positive. But then someone gave me an European network, big network traffic dump, and there was a lot of false positive, and when I investigate, I saw there was in false positive a lot of Czech or Poland domain name, which have not the same letter repartition as in French or in English. But there, after the development, based on already know DGA algorithm, came the Run Forest Run version 2 campaign with a new DGA algorithm, and the detection rate still stay at 100%. So when I look back, the first thing I do was to use the first mistake I've done was to use my data set for do the statistic and for the validation. So the first time I launched my script, I have 99% of true positive. So I thought it was not normal, and I discovered this little problem. Then when I spent time to improve the algorithm, I had the tendency to forget my target, which was only DGA, and I had the propension to, or the idea to detect all malicious domain, but it's not possible. I had to stay focused on DGA. And yes, it was in 2012, and at this time there was not a lot of public POC or research. And if this kind of thing interests you, I recommend you to look at data mining technique, to use multi-criteria decision analysis to aggregate the different level of scores, not be too technical or too formal. I think the common sense approach is better, and I recommend you to read this paper. So lesson learned from robotic applied to cybersecurity. Very interesting. And also, if you want to see something functional, I recommend you to look at the WordStat Splunk's add-on. And finally, what I learned after all of that is that security components, I think security components are assessing the threat by answering to one question, the how question, which is a technical question. So for example, how antivirus protect us? They are responding by the question, how malicious software infect a computer? It's inject code on the machine, it's play with registry key, or it's achieve privilege they don't normally have. But I would like to propose you to change the question, because changing the question, it's changing the vision, and to switch from the how question to the why question based on motivation, and we can come up with something like that. So why does the malware change the registry key to infect a computer? Why to contact the internet? Why to contact its botmaster? Why to do its job? Why? So that a man or gang can do money. And I think we should have more vertical approach of security and not layered, vertically layered. And I really want to thank the BotConf organizer for that, because I think we achieved that during these 2 days. Thank you.
Questions?
Very good talk. I really enjoyed it. Small questions. Did you try Kolmogorov complexity?
I thought about it, yes. But it's just an idea. But I thought about the Kolmogorov algorithm to try to classify DGA, because depending of the length of the string, it gives you the number of lines of the algorithm, and so yeah. But I don't implement it.
One simple way to implement that would be to use a compression tool and look at the amount of compression. It approximates the Kolmogorov complexity. Another question I had, you mentioned that you removed the top level domain from the string. It seems like one way to bypass your algorithm would just be have a lot of put the DGA function at the very beginning of the name and have 5 or 6 levels of names with common words, or just there's some DGAs that actually pick dictionary words. But did you actually, when you got the large data set, did you see anybody trying to use that sort of technique?
To use which technique?
To essentially move the DGA string to like a 5th or 6th or 7th level domain, which allows more common words to be in the domain name.
Yes. That's why, yeah, I don't explain it, but when it passes through the domain trap, it's split into TLDs, domain, and then all the subdomains. And in the aggregation part of the score, if you have 5 subdomains, the domain and the TLD, which seems clean, but they are highly suspicious subdomain, it's leverage, yeah, an alert.
You were mentioning there is not so many research on the run forest run DGA on the 2012. Yes?
No, for the overall DGA case. Run for restaurants, I saw a lot of work,
Okay.
but yes,
Okay.
on blogs and so on. Yeah.
Another question? Oh, okay, great talk. Thank you.